Hello everyone, I'm Aseem Jakhar, co-founder of Exploity, and today we are going to be talking about firmware security, specifically Dell's ControlVault chip firmware. And I have with me today Philippe Laulheret, Senior Vulnerability Researcher at Cisco Talos. Welcome to ISMG Studio, Philippe.
Yeah, thank you for having me today.
So, in your latest revault research, Philippe, you uncovered vulnerabilities specifically in Dell's ControlVault chip firmware that enabled persistent compromise. Can you walk us through the issue and the methodology you used to reverse and exploit the SoC?
Yeah, for sure. So the project started, I was curious of what was running in the system, one of the machine I had. And it got me to look into that ControlVault device that was just popping up in my system. And it turns out you can, obtain its firmware, it's part of the install files that you get with ControlVault. And I started reversing that. There was some interesting challenges because part of it was encrypted. So there's always this excitement of trying to find how to decrypt the thing. And so eventually I was able to look at the main thing and start looking for vulnerabilities in that. And I found multiple vulnerabilities that, combined together, lets you first get code execution on the firmware. So that board is runs on standalone RTOS, and a regular user on Windows can talk with it and so get code execution. And from there, I was able to leak secrets that are stored on the chip itself. And with that, having those secrets, I was able to tamper with the firmware of that specific device and patch it, and make it malicious and send data back to Windows that would exploit other components of ControlVault. And with that, you can get code execution as system on the host, so in Windows. And because that ControlVault device is also used to interface with a fingerprint reader, you can trick ControlVault into approving any fingerprint that touch the fingerprint reader, thus bypassing the Windows login if it was set up that way.
Oh, nice. And when you say talking from Windows to the chip, is it like a standard Windows API that allows you to communicate with the chip?
So that board that's inside your laptop, and here you have a connection onto the motherboard. It's 26 wires, but really two of them are USB. Mm-hmm. And so on the Windows computer, it appears as a USB device.
Okay.
And then you have a driver that talks with that, and the user level APIs talk with the driver.
Oh, that's interesting. So this is a two-part question. Mm-hmm. One is from the development side and one is from the usage side. So what lessons can firmware security teams and developers take away from this kind of attack surface? And the second one is, how should enterprises rethink trust in these embedded security chips like TPMs and secure enclaves?
Yeah, of course. So from a developer standpoint of the firmware, I think what I've seen is you want to mitigate. You want to make sure you have the best firmware mitigation you can have. In the case of ControlVault, there's no SLR, there's no stack cookie in the firmware, so it makes it much easier to exploit. And I think ControlVault has existed since 2010, and there's a lot of legacy code and even potentially dead code in the firmware. For instance, one of the fix for some of the vulnerability we reported was just to remove the function because it wasn't used anymore. And so I think for firmware developers, maybe thinking about how can you integrate the latest mitigations in your firmware is important, and also revisit as much as you can is this function needed still, and clean up the code if it's possible, And for what was the second part of the question?
The second part is, how should enterprise users rethink, trust in these chips like TPMs and secure enclave, because their job is to do security, right?
Yeah. So I think on that side, it's interesting because, as you said, those chips, their job is security. So it should increase, improve your security posture. but it also can bring, a new attack surface, that, you may have to mitigate against. So I think for the enterprise user, really, it's at best, I think what they can do is understand or try to understand what is the security exposure of the devices they get into the system. But it's more, it depends of, what the vendor share with them. And I think at the enterprise level, you might not have a choice. It's like you're going to have that in your machine. So maybe I think, if you want to improve that, it's like you need to investigate and maybe like do what I did and, reverse engineering the chip is maybe like a little hard, but trying to seek more information to like understand better the security posture of the device.
So do you see that there's a clear divide or separation between the development process and the security, irrespective of whether the product is a normal product or a security product? Because these kind of things, from my assumption, is things like ASLR and stack guard. These kind of things should be caught up during security testing for these chips.
Yeah, so my job is to look for vulnerabilities, not write firmware. But my understanding is that depending on how the firmware is developed, newer software, newer firmware, like brand new devices, may have a better chance here because like the awareness towards security is more present, and certain organizations are going to include the security of the device from the beginning of in the inception of the project, while other like manufacturer that have their thing existing for like decades, we have to catch up, and so it creates this kind of challenges where updating your build chain and so on might be like a problem.
And you also found multiple vulnerabilities in Microsoft ClipSP drivers, and things like signature bypass, privilege escalation, sandbox escape. So what were the issues with the driver, and what flaws stood out to you in the driver's design?
Yeah, so that one was there was a project from like over a year ago, and on that one I was exploring Windows security, and I was like, I want to look at some drivers and maybe find some escalation of privilege, which ironically was the same impetus for like that project. But for ClipSP, something interesting. So that's a first-party driver from Microsoft, but that one was also this one was obfuscated, and you like self-decrypt and so on. And so when I started looking at it, I was like, why is it obfuscated? Why is it trying to hide? And so I spent some time figuring out how to deobfuscate it. And then I was able to start looking at it, which, I don't know, maybe you can see the similarities with my process on the Revolt attack. And inside that firmware, there were like, actually also, I believe, some legacy code that was parsing license blob. And by looking at that code, yes, I identified a signature bypass, which was like really easy. The firmware would accept, license file for, Windows Store and that type of things. And you could just append more data at the end of the license blob. And if you knew how to talk with the driver, which was, complicated and obfuscated as well, if you could just send, like an arbitrary blob and add more data to it, it would just parse it. And that was the easiest signature bypass, because you just append data at the end. And with that bug, I was able to explore the parsing of the license file, which, otherwise I shouldn't quite been able to do, because, like those are done by Microsoft or maybe by developers, and that expanded the attack surface to, all the processing code of the license. And that's how I found more vulnerabilities that led to, sandbox escape and so on.
Yeah. So from your experience in finding vulnerabilities in drivers and firmware, do you see a pattern in design development flaws other than common mistakes like down checking or?
Yeah, I mean, I think to me, that's my approach to it is like, if you have something that's going to be, encrypted or obfuscated, or less security researchers are going to look at it. And as a consequence, there might be like, you'd say like low hanging fruits. So like bugs that are like fairly easy to find if you look at them the right way. And I feel like it's a kind of a pattern of almost security by obscurity, where nobody looks at your thing, so you believe you're secure, or at least nobody challenged that assumption. But I think in the end, like transparency would improve the security posture, and that's why we see on things that like under more attack, like either like open source code or Windows drivers and so on, like things that more people look at, like the bugs become much harder to find. And so by being open, it becomes easier to look at and improve overall.
And so you've worked on Windows drivers and firmware embedded systems as well. So for someone wanting to move from traditional binary exploitation to doing security research on hardware and firmware, what are the key skill shifts or mindsets that do they need to have?
Yeah, so I think it's each exploitation niche, if it's like Windows, if it's like phones, if it's like firmware, have all the like little like specificities. And in the case of firmware, you're going to have like some pragmatic problems, like how do you get the firmware? Like maybe it's encrypted. You don't have an easy way to access a console, so maybe you have to solder something on the board or prop the things. And so you kind of like, that's the first step is to learn kind of that, but it's really not that complicated. Like I think if you take, like a three hour, if you spend a little time, learning hardware hacking, you can unlock, the access to, all of those low-hanging fruits of like, nobody looked at it, so it's secure because nobody looked at it. And there's like a lot of like vulnerabilities like hiding there. And then if you want to go a little further, depending on what kind of targets you would consider, like, like a home router, for instance, is likely going to run Linux, and so it's like, Linux problems. But if you look at maybe some medical devices, they might have like a real-time OS on them and talking directly with the chip. And in that case, kind of like if you can learn a bit of embedded programming, or, you don't have to reverse engineer, maybe you can forward engineer and, learn those concepts like, MMIO or like special function register or like these kind of things that are like specific to if talking with a microcontroller directly. Yeah. So if you can understand those, it's easier to reverse the thing and explore that. But that's way more like if you want to target, more like real-time devices as opposed to just, you like random IoT device that just run Linux.
I like how you explain it forward engineering as well, in addition to reverse engineering. Yeah. Thank you so much. It was a pleasure having you here.
Yeah, likewise.
We were speaking with Philippe Laulheret, Senior Vulnerability Researcher at Cisco Talos.